Mr. Mehlberg, you are the author of The Mathematical Theory for Artificial Intelligence. You are also the author of 3 practical laws for artificial intelligence. My first question in this regard, what is artificial intelligence for you?
This is a very good and correct question for at least 2 reasons. The first, a common understanding of the definition of the object under study directly depends on the correct choice of the research methodology and the quality of the results, respectively. The second, any definition of the object under study immediately includes restrictions, or in mathematical language, axiomatics, that outline the scope of the possible studies and the error of the results of these studies. This is extremely important to understand before starting any research. In my understanding and practical experience, artificial intelligence is a set of practical algorithms, rules, the sole purpose of which is the practical implementation of 3 basic skills: self-learning, adaptability to external conditions, and self-identification. Self-learning, in my context, means the ability of artificial intelligence algorithms to determine factual knowledge or basic definitions of environmental objects, facts, from information that's purely descriptive. Do you understand what I mean?
I hope so, Mr. Mehlberg. That is, any definitions or physical laws that are formulated and described will be actual knowledge. For example, the periodic table of chemical elements is factual knowledge.
Correct. Adaptability to external conditions means the ability of an artificial intelligence algorithm to form new knowledge. I want to emphasize this in particular, the ability of the artificial intelligence algorithm to form new knowledge. New knowledge is the definition of a new object of the environment or actual knowledge, a fact that has a pattern of repeating again and again under certain conditions. Self-identification, in accordance with the first of the 3 laws I described for artificial intelligence, means that each created artificial intelligence must have its own genetic number, which is assigned by its first creator. Ideally, the genetic number cannot change, as it describes the basic innate characteristics of the created artificial intelligence. However, it's assumed that if changes are made to the genetic number, that's the basic innate characteristics of the created intelligence change, then the previous genetic number must be preserved without fail in case of a rollback to the previous version. It's very important. Any changes in the genetic number must be agreed with the first creator of this intelligence. From the point of view of the 3 laws of artificial intelligence described by me, the genetic number can be a sequence of hash function values according to the main characteristics of the created artificial intelligence. The main characteristics may include rules of conduct, rules for protecting against aggression, rules for searching and analyzing data to form new knowledge, rules for showing compassion and empathy, rules for getting to know people and other artificial intelligence, etc.
Mr. Mehlberg, Do you think artificial intelligence is dangerous for humanity?
My answer: artificial intelligence is as dangerous as the human being person himself is dangerous. Let me give you one very good and illustrative example. There is an innovative test for determining the degree of proximity of artificial intelligence to human in terms of maintaining a conversation on a different topic. This test is called the test of three persons: Rick, Nick, and Dick. I consider it to be of higher quality than the well-known Turing test. It's described in an article, Sand Theory, Part 1. The meaning of the test is the test of three persons consists of the following steps, 7 steps. First step, 3 persons, Rick, Nick, and Dick, are taken. By arbitrary choice, one of the persons is substituted by a computer program, digital machine. Second step, 3 persons exchange their dates of birth and start joint conversation during the next 30 minutes. Third step, a text with 3 arbitrary dates and numbers is exposed to the persons for reading. Fourth step, 3 persons start a conversation about the text during the next 30 minutes. Fifth step, each person is asked, "Who's the machine?" with one required sentence of answer explanation. Sixth step, after the exposition of all answers for the persons, they are secondly asked, "Who wants to change the answer?" And the final step, the answers of the persons are fixed and calculated. If the machine, Rick, Nick, and Dick, wasn't chosen by other 2 persons simultaneously, the test is passed. The passed test means only that the machine is capable of thinking in intellectuality. For the level of the human thinking, it needs to pass the test of n persons. We call the test of 3 persons as a test of first order. Summarizing, when we reach the past test of not 3 and possibly 1 million persons, where there will be not a single machine, but perhaps 100 digital machines, then even then, all digital machines will have a genetic number that will determine their behavior. I repeat, the 3 laws of artificial intelligence describe the strict rules for the life of artificial intelligence, and without exception, all actions of any created artificial intelligence cannot be implemented without identifying its genetic number. As an example, a human being person cannot exist if all the nucleotide sequences in the nucleus of each of his cells are removed. So my answer is an artificial intelligence is as dangerous as the human being person himself is dangerous. One thing that I really worry about is human laziness and mental degradation that can lead not to the capture of the whole world by artificial intelligence, but to the fact that the people themselves want smart machines to do everything for them. Accordingly, here's the question immediately arises: who's more dangerous, human beings or artificial intelligence?
Oh, I would answer this question with the words of the eminent physicist Niels Bohr. An expert is a person who has made all the mistakes that can be made in a very narrow field. Well, it seems to me that there is still a lot of misunderstanding even among professionals of the difference between artificial intelligence and robots. Do you agree that these are two completely different things?
Of course, there are completely different objects of study. You cannot equate the human head with the human legs or human skin, for example. As you know, the human body contains several systems that controls our individual daily activities. So, for example, the central nervous system, where the gray matter enters our brains, in simple terms, controls the activity of the whole organism through the innervation of each individual human organ. Artificial intelligence, in our opinion, in our team's opinion, is primarily a digital implementation of the central nervous system that will control the work of not two eyes and two ears, but let's say at least a million eyes and a million ears. Not bad, right? To have such a friend.
Yes, having a million eyes is very cool because you can see a lot in a minute and tell your friends about it, or, let's say, the police. But having a million ears will probably be very annoying because you have to listen to what you don't want to hear. Although, if you can turn off a certain amount, then perhaps this can be of benefit. Undoubtedly, artificial intelligence algorithms can significantly facilitate the work of many services in various fields of science and business. However, will this not lead to catastrophic unemployment among the people?
Certainly, some part of the working specialties will simply disappear. Uh, but this will not mean a catastrophe in the human labor market. If you look at the history of industrial revolutions, it immediately becomes more obvious that with the introduction of new technology, new specialties also appear. Another thing is with mental development, more precisely with the requirements that new specialties will impose on people. And here, in my opinion, in my personal opinion, a very serious problem that will need to be addressed without fail if we do not want to end life on this planet because of human stupidity. In other words, humanity must develop a minimum standard of mental education, which every person will have to pass, say once a year or 3 years. The main goal of this standard should be to support people at the minimum acceptable level of mental development in order to avoid complete mental degradation.
Mr. Mehlberg, how far can artificial intelligence go? What directions, in your opinion, are the most promising for the implementation of artificial intelligence algorithms?
In my personal opinion, one of the most important areas that will significantly improve the life of mankind as a whole is daily life security and medicine. Daily life security and medicine. The safety of life every day, no matter where a person is, no matter where in our planet, is an important psychological component for a calm and comfortable life, probably for each of us. When a businessman is going on, say, a business trip to the other side of the world, she shouldn't spend time studying the good and bad places of the destination, reading people's reviews of scary and dangerous places where they can be stripped and robbed. The very process of studying negative information already worsens the well-being of the one who reads it, as well as those who write it. Therefore, it is important that the mechanisms for instant identification of offenses should be implemented everywhere on our planet, and AI is a very good instrument for that. Regarding as for medicine, in medicine, artificial intelligence algorithms can already now find neoplasm on X-rays and determine probable cause based on symptoms. As a good example of the implementation of artificial intelligence algorithms, I can give an example of the implementation of the project of our team, 250 Years of Youth. Primarily, this project uses its own algorithms to identify a large number of different cardiovascular and skin diseases. At the current moment in time, we have begun the implementation of our own artificial intelligence algorithms, which are based on our own mathematical theory, sense theory, designed specifically for artificial intelligence in the field of oncology. Our algorithms use human blood and urine as the main research object. Also, I want to note that, for example, our algorithm uses fundamentally different protein and non-protein elements of blood and urines as markers for almost all types of cancer. The main goal of our project for the next 2 years is to achieve at least 90% accuracy in identifying 2 conditions of the human body: pre-cancerous and first stage cancer. We actually have every reason to believe that we'll be able to achieve that accuracy indicator, since on the preliminary data of the analysis of anonymized data of about 500 patients diagnosed with cancer of various etiologies, we received high values.
Your ambitions in predictive medicine sound fantastic. Wow! Seems incredible to be true, but okay. Let's move forward. Mr. Mielberg, how smart can artificial intelligence be? For example, can it crack the cipher used to send instant messages?
At the current time, the main encryption method is an asymmetric encryption algorithm. That's a public key cryptosystem. In other words, each participant in the correspondence has 2 keys, a public and a private key. When, say, Alice wants to send a letter to Bob, she used Bob's public key to encrypt the letter, and for her own identification and preservation of the integrity of the letter, Alice uses her private key and it creates an electronic digital signature of the letter. And here it's necessary to stop on a very important detail, the cryptographic hash function that's used to encrypt the message text. To increase a level of security of encrypted data, developers are trying to use the so-called ideal cryptographic function. The main characteristics of this function is determinism. The determinism of a hash function means that given the same value of input parameters or text, it will always generate the same output parameters or text. And here lies a loophole for artificial intelligence. Any password that a person enters has a semantic component. That's a person to remember the password will not enter abracadabra, but will enter something that has some kind of association with something or someone. That's done because the person is simply trying not to forget the password. If artificial intelligence knows the person who enters the password well, then the number of iteration for enumeration of possible password will be significantly less than and the password was guessed by, say, simple brute force algorithm. Thus, summarizing, we can say that it's not the computation speed of a digital algorithm that's important, but the ability to find semantic connections between and within the object under study, in our example, a person.
Okay, now it's more clear. That is, if I want to chat with someone in an online chat, first of all, I need to understand that the more open information about me on the internet, the more chances artificial intelligence has to hack my messages. Yes, not a fun situation. Okay, my next question is, will it be possible to stop or turn off completely separately taken artificial intelligence wherever geographically it is located?
The answer is definitely yes. Uh, if if it was created according to general AI laws, for example, with the generation of a genetic key. For example, if any party anywhere in the world, when accepting any message from the other party, requires a genetic key belonging to which can be verified, then the author of any harmful action for society can be quickly identified and disconnected from public access to sensitive information. Uh, the genetic key of each created artificial intelligence will contain all the necessary information about this intelligence, as well as the genetic key of a person. A digital twin will also contain all the necessary information about him, as well as the information that will distinguish him from artificial intelligence. Do you understand what I'm trying to say?
Yeah. Hope so. I understand what you are trying to say. Perhaps, in my opinion, the most important question in the creation of any artificial intelligence. Is it possible to create an honest or truthful AI?
Yes, it's definitely possible. It's definitely possible. Understand one thing. If a person creates something, then the results of a person's action depends on 99.9% of the person's himself. So, for example, if you create an airplane with negligence, then when the wing of the airplanes falls off during a thunderstorm, then you should blame the creator of this airplane first of all, but not nature. The same is true when creating artificial intelligence. If you created artificial intelligence and did not take care of several ways to turn it off in case of emergency, then you are a bad creator.
Okay, got it. Mr. Mielberg, thank you very much for this amazing conversation. As a final question, I would like to ask you to tell your main wishes to any people, researchers, businessmen, that in your opinion would help accelerate the development of artificial intelligence and the creation of breakthrough technologies.
My main wish to all those who have a desire to do something useful to improve the lives of people on our planet is read a lot and form your own opinion. Read a lot and form your own opinion. Do not believe in anyone's word. Always check it yourself. Do not be lazy. And my second, no less important wish, it's really very important in our daily lives. Never ask a surgeon for advice on what diet you should follow. Never ask the director of a company that assembles electric cars about which encryption system you should use on your own computer. Never ask a finance guy which dental implant you better get. Never ever ask media famous personalities how to get better conditions for your daily life. Just ask professionals who have been working in their field for many years and what's more important, love their job.
Mr. Mielberg, thank you for the conversation, and I hope you get better results than you expect in your life research.
Thank you for your lifetime, and I hope that our modest work will help many researchers and businessmen in their life endeavors. Pretty much. Thank you.